So from today we are starting, FX, FX in Maya and dynamics. Okay. So in the last class, I have given a brief introduction. Only I think one person was there. So did you practice Lendl? So have you tried?
Yes, I've tried.
Okay. So what you have to do is, like you have to go to FX here. Okay. So there are basic things which you have to keep in mind is N particles. N particles, N stands for nucleus. Nucleus is a solver here. How heart is for a human body means which functions, the main functions. Similarly, solver N nucleus is a main, uh, you know, a functional part for the entire particle system. Okay, of N particles. We will see this. Okay, here if you see here, emit, these are a part of nucleus system. You have certain legacy particles. Legacy particles are standalone system wherein I create some emitter, I create springs, emit from the object. There are certain things. Okay. Let us see these things first. What and all elements are there in this? What is this emitter? Okay. So what you have to do, you have to go to FX here, choose FX in particle. I'm selecting emitter, create emitter. See, the name itself says emitter emits something. Here it emits particle. Okay. So I just create an emitter. Let us see how does this looks. So if you see emitters are emitting particles. The shape of the particles are in, um, it's like a point. Okay. Let's observe. It's like a point, right? Now I select this particle. If you click on this in the attribute editor, particle shape, there are some types of particle. Okay. Here, see the name is here, the whatever the names are there, the wordings are there. Everything is, like simple. It is understandable. Now, when you select the particle, max count, emission attributes. Okay. So we need to see emitter tab also. We'll see that level of detail. It's called LOD, inherit factor. Inherit factor is by default, what do you call hereditary? Okay. uh, so it will, let's say for example, here in normal language, hereditary means um, we uh, we have some properties or some uh, some common properties or common thinking or common features from our parents. Hereditary here, inherit means whatever already the values are there, it will have the same values when a new particle is generating. Okay, like that. So we'll see that. Now lifespan attribute, lifespan refers the birth rate and the death rate of this particle. So it says live forever. All the particles will live forever here. Okay. So until whatever frames is there, either it is 500 frame or 1000 frame or 10,000 frame, these particles will live forever. Okay. So you can even define that. So by changing constant one value is that means it's just a second. Particle birth and it get died. There is a random range is also. The random range refers, let's say I want the particle to live for around 4 seconds and plus or minus 3. Minimum 3 seconds will be there. Between 3 to 4, this particle will die. Okay. It's like that. So particle birth is there somewhere, plus or minus, it dies. Okay. Like that. So that stands for this random range. For time being, let it be leave forever. Okay. We will see this time attribute, collision attribute, all this we'll see. Main thing is render attributes here. Main is render attribute. Okay. So this render attributes, it says the type of particle. So right now particle render type is point. Let's say for example, see for time being, like we need to render this using hardware, Maya hardware. I can render this particle in hardware. You can see as a point. Now I change this to uh, streak. Streak. Okay, I'll tell you first thing. There are 9 type of particle, 9 rendering type of particle. I'll tell you what are those. Multi-point, multi-streak, point. These are renderable. Sphere, sprite, streak are renderable. Blobby surface, cloud, and tube. These are software renderable. Maya software renderable. Okay. We have one type of particle called numeric. Numeric is a non-renderable particle. We cannot render this. Render means you cannot get the output. Numeric is only for the display purpose. Let's say I take the streak, multi-streak. Okay, so it looks like this, and when I take a render in hardware, you get the streak effect. Okay, so when I take this in blobby surface something, so when I take a render, you get something like this. Basically, like in software, we get a good output. SW stands for, like software render here, blobby surface, cloud, and tube. Whereas rest of the things are, like you can render it in hardware. Okay. Whereas numeric is non-renderable. Excluding numeric, there are 9 type of particle. Including numeric, there are 10 type of particle. Okay. So I just change this to streak. The streak looks like this. Now, the next point is, after I pick some type of particle, how do I check the attribute of this? Let's say I want to change some settings. I want to do some modification for this particle. If you have selected streak or any particle, click on current render type. It will go to the attribute of this particular particle, streak, wherein I can increase the tail size, tail fade I can do, line width I can give thickness, increase or decrease the thickness. Similarly, if I choose point, I can define for point. Okay. Similarly, I choose sprite, I can define for sprite, like that. Okay, for time being, I'm just picking streak. Okay, got it? So that,
Yes, sir.
there are some
Yes.
array attributes. Array, actually, it's a connective attributes. There are some programming part and all we can enter here. We can create some, have some programming things. We will see this. You guys will see in advanced Maya. Okay. For time being, like type of particle, how many type of particle, we'll see. Now I'll coming to emitter here. Emitter. How are you getting particle? Particle are, I'm getting particle because of this emitter. Emitter is emitting the particle. Now I'll come to emitter. Emitter. The name itself says, the word itself says emitter emits something. Here it is emitting particle. Now I'll come to emitter. This is omni emitter. The current emitter which it is there here, which you see here, this is omni emitter, and omni emitter is emitting particles in 360 degree. That means in all the angle it is emitting, and per second 100 particles are emitting. How many? 100 particles are emitting. Okay. Then what I'll do, if you click on this type of emitter, there are 5 types of emitter. One is directional emitter. The name itself says directional emitter. In which direction you want your particle to move, you can do that. Another is omni emitter, which you are able to see now. Another is surface emitter. Surface is, you have to select any object, you have to create any object and select the object, you have to do the emission. Okay, so based from the surface, particles will emit. Then let's say curve emitter, you have to create a curve, and then you have to select the curve and emit from object. Then from the curve, particles will emit. Then again volume. Similarly, You have to select some shape. From the shape, if you give emit from object, it's like a volume emitter. So currently, let's see omni emitter, or let us see directional emitter. So when I play this, you can see some type of particles are emitting in this particular direction. Okay, I want to change the direction. So if you come down, it says direction X, direction Y, direction Z. Right now, it is in emitting in X axis. I don't want in X axis, I want in Y axis. Okay, so when I do it in Y axis, you can see particles are emitting in this particular direction. You have something called minimum and maximum distance. So I'll tell you what is this. Now let's say the emitter is here. You see the emitter is here. Minimum distance is 0, max is 0. That means from the origin of the emitter, particles are emitting. Let's say if I give some value 3, that means you can see from here to here 1 point in the grid, from here to here 1 point. Now what happens when I give 3, from the minimum distance 3 it will do. Okay, max also I'll give 3. Can you see? It is emitting from here, but my emitter is here. Okay, so this is just adding a distance. That's okay, I don't want it. There's something called spread. What is this spread? Let's say currently, see the particles are emitting like this. And if you see here, there are 100 particles are emitting per second, but I see only one line. But when I give spread, when I increase spread value, you can see particles are emitting in this way, right? You might have seen a flower pot cracker. Have you, you know, crackers, flower pot cracker, burst crackers. Are you guys aware of the crackers?
Mm-mm.
Fireworks.
Fireworks, yes.
Yeah. Those fireworks are available in Switzerland.
Yes, they are.
Okay. On which event, you guys use?
New Year.
Okay.
On the New Year.
Okay. Okay. Great. So here also on the New Year, or there is a festival called Festival of Lights, Diwali. So in India, people celebrate. That's a very big fest. So assume now let us say we are creating a type of firecracker which looks like a flower pot. Okay. So something like this, which is coming. Then speed. What is the speed of the particle now, which is emitting? If you see for everything, what you have to do, you have to stop. You have to go to first frame. Then you have to play. In dynamics, you have to do like this only, because every time the values Maya which will read, it will read from the 0. Okay. Otherwise, let's say for example, if I do like this, you won't get a proper result. So you have to go back to first frame, then you have to play. Every time you change some value, you have to do this. Now let's say speed I'm increasing to 15, and wow, it's super fast. Okay. Then what I'll do, random. Here all the particle speed is 15. I don't want to happen like that. So what I'll do, I'll give 12 here. Speed randomness is 12, wherein the particle emission minimum speed of the particle is 12, maximum is 15. So the particle speed, it is somewhere in between 12 to 15. It is not the same for all the particle. Okay. Guys, this dynamics, the effects part which we are learning, this is a pure science, especially physics. Okay. You might have learned in your school, like in primary or secondary education or higher education. So in physics, you have learned physics, right, everyone? Everyone has learned science, physics, right? Fundamentals of physics.
Yes. Yes.
Yes.
Great.
Yes.
So you just recall these words which you have learned: speed, velocity, turbulence, collision. Okay. So collision, simple example: an asteroid or meteor, when it collide with the planet, any of the planet, it shatters. Shatters is, getting into pieces. And simple derbies called, the pieces of those either planet or the meteoroids. So it gets into smaller pieces, and it it flies away, or like it travels in the universe like that. Here so many things we can do. There are different forces. So normally, where you are there, let's say if you turn on the fan, there is a force. What force is that? Can you tell me? You turn on the fan, what force is that? It's a wind force, right? You have a wind force. Now, let's say for example, you take some object, lift it, and you just leave, release it, it falls on the ground. Which force is that? Okay. Simple example: assume you are standing on a first floor, okay, and you jump. What happens when you jump? Will you stay there or you fall down?
You fall down. It's
Yeah.
gravity.
Gravitational
Gravity.
force. Great. So like that, there are many forces are there here, okay. Along with, see, by just creating an emitter, creating different type of particle, okay, by only creating this emitter and particle, you can't achieve an output. You should have a force also. So if you go to fields here or solver, there are some forces here. You can create air force, drag force, gravitational force, Newton, radial, turbulence, uniform, vortex. Uniform force is like, for example, in a war scene, if you have seen the movie Troy, or like war movies, where so many hundred thousands of soldiers will be there. How can we create all that? In real life, it is not possible. Those sort of shots are created using dynamics. Okay. uh, I'll explain, one after the other. So turbulence, for example, lot of windy, lot of noise, or for example, wave. Okay. So on the ocean, if turbulence is more, the waves height and all, it will be really, extreme. So Newton, this is based on Newton's first law. How many laws are there, Newton? Any idea? Newton's law. Have you heard of Newton's law?
Yes.
Okay.
No, sir.
There are three types of Newton's
No,
law.
sir.
Yeah. Newton's laws of motion is there, its momentum is there, attraction is there, equal and opposite reactions. Like these kind of things are there. This based on the an attraction law. Okay, wherein I'll tell you, it attracts. You select any particle and you apply Newton, it attracts. It's like that. Okay. So air, drag, gravity. Obviously, you know what is gravity. Air, different direction. We can give for the particle. Okay, we'll see all this. Vortex is like twister. You know twister. uh, you get a wind in a twister shape, or in a river you will be having twister. That kind of effect you can achieve. Or else when you're creating a universe set, um, the planets will revolve around the sun. uh, like those kind of effect and all you can achieve. We'll see all that. Okay. So now what I'm doing, let us see gravity. I want to see how does this particle look when I apply gravity. I apply gravity. Okay. And for this particle, assume this is 1, and I haven't given any value. So now if I play, see, for the particle I have applied gravity, thus all the particles are hitting down. Okay. Now assume in the emitter I'm increasing the speed to 15 and random to 12. So when I play, particles are going up and coming down. Due to speed, particles are, like reaching up to some height, then it's falling down. So the spread seems to be more for me. So I reduce the spread. Then if I see this, I'm having an output like this. Great. So this is looking good for me. So then what I'll do, I'll create a plane. I create one plane like this. Okay. Then what I do, I select the particle. What I want is when the particle uh, moves up and when it falls down, I want the particle to hit this surface. I don't want particle to go down. When the particle falls back, I want this particle to hit the surface. Okay. So I select this and I select the particle to hit the surface. What I have to do, I need to create a collision, right? So select the particle, select the object, go to N particle. I'm gonna collide, make collide. I click on collide. So when I do that, particle is going up. It is hitting the surface and bouncing back. Observe here, particle is going up, it's hitting the surface. Yeah, it's bouncing back. Okay, I'll tell you why it is. When you create a plane, it's a normal plane. When the particles are hitting the surface, that means select the particle, select the object, and if you do make colloid, a new function will automatically connect to this particular plane, that is called geoconnector. Geoconnector. Okay. So here there are certain values: tessellation factor, resonance, friction, offset. Tessellation factor is nothing but the quality of the collision. Let's say I want this to be 1000. Resonance is fine. Friction. What is friction? Can you tell me what is friction? Any idea what is friction? You might have heard this word friction.
Something rubbing against each other.
Huh?
Yeah. Okay. Um, yeah, you said the correct thing. Let's say, for example, so you both hand, you try to rub each other. What happens? When you rub each other, it generates heat, and
It's just good.
yeah, and the speed is not that great. Without that, without touching each other, you can just move your hand quite faster, but while touching you can't do that. Similarly, uh, the track, you know this bullet trains and all. Do you know how does a bullet train works? Have you heard there is something called bullet train?
No.
No.
Yes.
Yeah, in Japan, in China, even in some other countries, like there are some bullet trains are there. The speed of the bullet train is 250, 300 kilometer miles per hour. Or I think fastest bullet train, the speed of the fastest, like bullet train, speed of the bullet train, 320 kilometers per hour. Okay. In Japan, it is there. Shinkansen bullet train. Like that. Here's, okay, this is another one, 300 kilometers. So like that. How does this work? When the bullet train, when it travels, basically the railings, the wheel of that, it will be little bit away from the, the bottom track. Why? Because the magnitude field is enabled when it is moving. Magnetic, opposite poles repel. It doesn't attract. How does the magnet work? Attraction and repulsion.
Yes, sir.
Yeah. It's like opposite poles are on, so that the wheels are little bit away from it's on the air kind of stuff. It will not be on the track. So when it reaches the station, the magnetic repulsions, like it's kind of on. wherein it attracts the track, the wheel will attract the track so that it generates a friction, so the speed reduces. Okay, so that's what here I'm gonna do with tessellation, with friction here. I make this as 0.5, friction as 0.5, and you observe what happens. It hits the surface. Okay, it's bouncing still. Okay, resilience I'll give 0.1. Okay, great. Resilience, instead of 1, what if I give 0.1, it reduces the bounciness. Let's say I make 1, back to 1. So when the particle hits the surface, it is bouncing back. I don't want this bounce to happen. That's the reason resilience. I give 0.1. When I do 0.1, it won't bounce again. Can you see? Now the particles are on the ground. Okay. So what I can do, friction, I'll give 0.2. In that case, it hits and the particle move a little bit. Okay, that's okay. Fine. I'm getting an output like this. Okay. So I'm getting kind of flower pot output. Then I would like to work on the particle shape. So line width, I'll give 2. Tail fade is fine. Tail size, I'm going to reduce to this much, 3, 4. Okay. So getting an output like this. Okay. So now what I'll do, instead of streak, I take multi-streak. When I take multi-streak, there are so many, in one place, I'll go to this one. In one place, 10 streaks are there. In one place, 10 streak. So what I do, I would like to read, okay, I reduce this. Instead of 10, I make it 5 or something. I increase this size. Okay, I reduce this. In emitter, 100 is there, no? 100 particles are emitting, right? I make it 500. Okay, particle shape. I can make it a streak to multi-streak only if required. It looks good. Great. We are getting an output like this. Okay. So now what I'll do, I'll select this. I would like to apply some color. So I'm selecting this. Okay. So down to this array attribute, there is something called add dynamic attribute. Add a dynamic attribute. In this, color is there. I click on color. There are 3 different things. Add per object attribute, add per particle attribute. I select the second one. Add per particle attribute, PP, per particle. Per particle, I want to add a color. So add attribute. When I do that, here you get RGB PP. This was not there earlier. Now we got this RGB PP. Okay. So actually, it's really interesting. You have to know the process. Then you can create, wonders actually in this. RGB PP is there. Okay. So here right click. There are certain things. Create expression is, I can create some programming stuff. Let it be. I would like to create a ramp first. Ramp is a 2D texture. I would like to create a ramp. When I click on this, I created a map, array mapper. Automatically this particular expressions come. Okay, I created a ramp. Then after creating a ramp, right click, go to array mapper, edit ramp. Go to right click, array mapper, edit ramp. Great. So we got ramp now. So I would like to add some color. Let's say first thing, yellow. I press 6. You're getting yellow like this. After yellow, I'm clicking here. I would like to give an orange. I'll click here. I would like to give like this. Then I click here. I would like to give red. Then click here. Like fire color I would like to give. Like this. Then this one. This. Then this is black. See, fire color. Okay. Then if you see, got it? Is it?
Yes, sir.
Yes, sir. Yes, sir.
So is it looking good? So add one more here. And I would like to give white color here. So here it will be white because it's of flammable. It's like this. Okay. So I can add even more. So what I'll do is go back, particle, line width I reduce, emitter, I'll make it 1000. 1000 particles are emitting per second. Okay. So when I do this, wow, this looks good. Okay. Any doubts up to here? We created a fireworks.
No, sir.
This is really interesting. We can create so many things in this. Okay, try to replicate this. Okay, and later, you know what I can do while rendering? I can turn on motion blur. There are some motion blur and all is there. Okay, so I can do that in Maya hardware. You have motion blur. I can enable motion blur. Okay, some count I can increase 16. I'll show you how to work on this. It looks really good if you do. Okay.
Yes, sir.
Later, see if I take a render with motion blur. Okay. So it will be good. I'll just go here. Blur. Increase blur. Shutter open fraction. Okay. Anti-aliasing. Render option. Then in the particle, there is something called use lighting. Okay, I'll turn on. Let me render this. Okay, I turn off this and I render. You get an output like this. You can see some blur and all in this. Okay, so do one thing, do up to here. Okay. Next class, I'll show you something different. Like I'll create some motion graphics stuff. We will create motion graphics. Okay. And
Yes, sir.
if you create
Yes.
5 to 10 different type of effects, you can make a demo reel in Dynamics VFX, Maya VFX. That will be really cool. Okay. Fine. Complete this. Currently, do this one. Whatever you are doing, other assignments, you do that in the weekend. So for the next class, I want to see the output. Okay. So you can reach out to me
Yes,
if you have any doubts. Okay.
Okay. Yes, sir.
Bye. Have a good day.
Bye.
Bye, sir.